The tool loop is no longer the hard part. The hard part is everything around it: state, approvals, credentials, sandboxes, evals, traces, schedules, channels, and deployment. Today on Fluid Coding in AI, we are comparing 3 ways to build the same production-shaped agent: plain AI SDK, Eve local, and Eve on Vercel. The question is not, can the agent call a weather tool? A plain loop can do that. The question is whether a framework removes the glue you actually write when an agent leaves the demo. That means durable sessions, human approvals, sandboxed file work, channels like Slack or GitHub, scheduled runs, evals, traces, deployment auth, and credential boundaries. By the end, the useful verdict is not which build is prettier. It is which parts become framework defaults and which parts still belong to your application. The baseline is the Vercel AI SDK ToolLoopAgent. The AI SDK docs describe agents as language models using tools in a loop, with the loop managing context and stopping conditions. ToolLoopAgent is recommended for most agent use cases because it reduces boilerplate, manages message arrays, centralizes configuration, and gives you reusable agent definitions. That is a good baseline because it is honest. You can see the model, tools, instructions, and loop behavior without a large framework-shaped project around it. In the AI SDK, loop control is explicit. Agents stop after 20 steps by default, and developers can set stop conditions, combine them, or prepare each step with different model settings, tools, or messages. That matters because loop limits are not just implementation details, they are safety controls. They decide how long the agent can keep trying, which tools it can reach, and when your app gets control back. A plain tool loop agent gives you the core loop, but you still design the guardrails around it. The first build is the cleanest to understand, but every production adjective turns into app code. Durable session state, crash recovery, turn ordering, approval screens, pause and resume, sandbox isolation, scheduled work, channel adapters, eval harnesses, telemetry wrappers, route auth, secrets, retries, and idempotent side effects all sit outside the simple loop. That is not a criticism of the AI SDK. The docs themselves say agents are flexible and non-deterministic, and that reliable, repeatable workflows need explicit structure, normal control flow, and error handling. Vercel introduced Eve on June 17, 2026, as an open-source framework for building, running, and scaling agents. The launch material positions it as durable by default, with sandbox compute, human-in-the-loop approvals, subagents, evals, and more. The important caveat is that Eve is public preview. The GitHub README says the framework, APIs, docs, and behavior may change before general availability, so the right posture is not replace everything tomorrow, it is test what the framework standardizes. Eve changes the project shape. It treats the agent as a directory. Common slots include agent files, instructions, tools, skills, subagents, channels, and schedules. Path-derived naming is central. A weather tool in the tools folder becomes the weather tool. A connection file becomes a named connection. A subagent folder becomes a named subagent. That is the first big difference from the plain baseline. Instead of building a registry by hand, you fill framework-known slots and let the project structure describe the agent. The file system model is not just cosmetic. Eve separates always-on instructions from on-demand skills, so long procedures do not have to bloat every turn. Subagents live under the agent. Schedules live under the agent. Evals live at the app root, as a sibling of the agent folder. That structure has a real engineering consequence. Local Eve changes the work from invent the harness to fill the slots, name the boundaries, and write the policies that make those slots safe. The biggest architectural shift is durability. In Eve, work is modeled as sessions, turns, and steps. Each turn runs as a durable workflow. On Vercel, that uses Vercel Workflow. Locally, Eve uses the Workflow SDK local world by default. The docs say Eve checkpoints at step boundaries. Completed steps replay from recorded results. Interrupted in-flight steps can run again. That is powerful, but it is not magic. If a tool charges a card, sends an email, or mutates an external system, you still need idempotency or an approval gate. Human approvals are where the difference becomes concrete. Eve supports approvals and questions to the same durable pause and resume protocol. Tools can declare approval requirements with helpers like never, once, always, or a custom predicate. The default matters. If approval is omitted, it behaves like never. The docs explicitly warn teams to require approval or safeguards for sensitive, irreversible, regulated, financial, healthcare, legal, safety impacting, user impacting, or external side affecting actions. In other words, Eve gives you the pause button. You still decide where it must be pressed. Eve also gives every agent an isolated sandbox. The Sandbox has a workspace file system where the agent can run shell commands and read or write files without touching the app runtime. The trust boundary is the point. The app runtime is the trusted side with environment variables, model calls, state, connections, and durable execution. The Sandbox is the isolated side with controlled network policy, no process environment, and its own workspace. That helps with file and command tasks, but the deployer still owns network policy, tool restrictions, and what results are allowed back across the boundary. Connections are where the production story gets more realistic. Eve can wire agents to external MCP or open API servers. The model does not see the connection URL or credentials. It discovers remote tools and calls qualified names. Static token auth can resolve tokens from environment variables, vaults, internal services, or OAuth exchanges, and tokens do not enter conversation history. Interactive OAuth can park the run durably while authorization completes. That is a strong framework primitive. It still does not choose your scopes, consent screen, token rotation, customer isolation, or incident policy. Production agents rarely live in one chat box. Eve channels normalize platform input, own continuation tokens, and decide delivery. The docs list options like browser UI, local tooling, Slack, Discord, Teams, Telegram, Twilio, GitHub, Linear, and custom webhooks or WebSockets. Schedules live in the Agent Schedules folder and map to Vercel Cron jobs on Vercel. But local Eve dev does not fire schedules on cron cadence, and Markdown schedule task mode cannot park for a human or OAuth sign-in. The defaults help. The edge cases still matter. Evals are one of the best arguments for a production-shaped framework. Eve evals run the agent against real sessions and grade the result. They can check whether the run completed, which tools ran, and what the reply contained. The runner drives the same HTTP surface users hit, so a passing eval means the agent booted, accepted a request, and produced asserted behavior. Evals support deterministic checks and language model judge checks, with hard gates and soft checks. That is much closer to how agent regressions actually show up. Observability is another place where structure matters. AI SDK telemetry uses open telemetry and is experimental. When enabled, it can record inputs and outputs by default, with options to disable those fields. Eve auto-discovers instrumentation and can produce an Eve turn parent span with AI SDK child spans for model calls and tool executions. It also emits workflow run tags for session, turn, subagent structure, trigger, model, token usage, and tool count. That is useful, but production teams still need privacy review, retention choice. The deployed Eve build is where Vercel alignment matters. Eve build compiles artifacts. On Vercel, Eve uses Vercel build output, Vercel workflow, Vercel sandbox, Vercel cron, AI gateway, and Vercel observability surfaces by default. Gateway-routed model IDs can authenticate through Project OIDC. Outside Vercel, developers use an AI gateway API key or direct provider packages and provider keys. But the docs are blunt about auth. Production auth fails closed by default. Scaffolded placeholder auth must be replaced before routes are exposed. AI gateway matters because agent workloads can move cost quickly. Vercel's June 2026 AI Gateway Production Index says gateway tokens grew 20% month-over-month in May, while spend grew 43%. For coding agent traffic in that report, DeepSeek drove 49% of token volume but 4% of cost, while Anthropic drove 28% of tokens and 70% of cost. That does not prove one model is better. It proves routing, budgets, fallbacks, usage monitoring, and app-specific evals belong in the production conversation. Here is the verdict. Plain AI SDK ToolLoopAgent is the best baseline when you want the smallest understandable loop and you are prepared to own the production harness. Eve Local changes the job from writing the harness to filling framework slots, tools, skills, subagents, channels, schedules, evals, sandbox behavior, and approval policy. Eve deployed on Vercel removes more infrastructure glue by aligning with workflow, Sandbox, Cron, gateway, and observability, but it does not decide your trust model. Auth, credentials, scopes, approvals, idempotency, telemetry privacy, budgets, and production state are still engineering work. If this helped you separate agent framework value from production responsibility, like the video and subscribe to Fluid Coding and AI. The next agent framework you test should not just answer a prompt, it should survive the messy parts your users will actually depend on.